I got 2 from 10. Well, I got 2.
You got
because
2?
I put it in the calculator. And I got that.
Okay.
And then this, I didn't know why, because when I put it in the calculator, it said that like.
Cost 3.2 is 0, right?
There was like a.
Well, what's cost 3.2 heading towards?
What is it?
Cost 3.2. What's that part heading towards? What's cost 3.2 heading towards? Or what's cost x heading towards? X goes to 3.2 is what I'm trying to say.
But it's saying on the left side.
Okay. So either way, it's heading towards the same thing. So cost x. The limit is x goes to 3 pi on 2 from the left, is that what you said?
Yeah.
Okay. So forget the left part for just 1 second, and just what is cos x becoming as x becomes really close to 3 pi on 2? Basically, what is cos 3 pi on 2?
The third. Is it the third? I don't know.
Well, it says here. I mean, it's saying the angle.
3 pi over 2 is 90, right?
That's D and E.
I mean, yeah. Yeah.
That's D and E.
It is D and E, but it's a specific D and E, and I think they want the specific direction of D and E. So here's 3 pi on 2, right?
Oh.
Here's an angle 3 pi on 2.
Yeah.
Right? But you're approaching from the left, so that means it's really doing like this. Oh.
Left would be counterclockwise, right? Or would it be clockwise?
I should be if it's to the left, it's a smaller value, right? You should have a smaller angle approaching a large angle, right?
Yeah.
So here's x, or theta. Let me just theta there. Same thing. Okay. So you have a smaller angle approaching a larger angle, which is ultimately 3 pi on 2. So you're approaching from the third quadrant. Okay? So if that's the case, it's true. This is heading towards, this bomb's heading towards 0, and this is fixed at 1, so therefore it's n infinity, but which one is it?
The negative infinity.
What's that?
Negative infinity.
Why say that?
Because it's down there.
What's down there?
The angle is beneath the x-axis.
Yeah, but it's really dependent upon this function. It's because all students take, it's because cos is negative down here. Okay?
Okay.
So it is negative infinity because of that reason. This cos theta is negative the whole time the
Well,
yeah.
even though it's on the y-axis, like the 3 pi over 2, it's still on the tangent side.
Yeah,
or is it because you're coming from the left side?
Correct, you're coming left. You're never actually going to reach this 3 pi on 2 value, right? You will never reach that value.
Yeah.
And since you're approaching from the left, you're always at a slightly smaller angle than 3 pi on 2, which puts you in the third quadrant. And for all of those guys in the third quadrant, cos is negative. If you're approaching from the right-hand side,
Oh, okay.
then you'd have a different issue, right? There, cos is positive. So
Okay.
if you were to put a little plus here, then it would be a positive infinity in that case.
Okay, that makes sense. Yeah. And what was the other one I had a question?
2.5 number 1.
2.5 number 1.
That's what you said, yeah.
I didn't write that down. Oh yeah. Wait, I do have it. I just wrote it as number 2 when I see. But I didn't understand any of that at all, like with the example of like with the number or any of that. So I did it like 3 times, and only because I did it 3 times I got the answers, but I don't understand it at all.
If f is approaching 800,000, g of x is going towards infinity, as x goes towards infinity, choose the correct answer below. Okay, so all the limits are the same. The only question is what do they turn out to be on this side, right? All the structures are all the same here.
Mm-hmm.
So as x goes towards infinity, the top is going towards 800,000. Finite, non-zero value, right?
Yeah.
Okay. The bottom is getting arbitrarily large. G of x is going towards infinity. So you have a finite thing above, and you have infinity below. So think about a fraction. If you had 800,000 above, and on the bottom, it can just get as big and big as you want. So that fraction is getting really small.
Oh.
As denominators get bigger, fractions get Right. As long as the top is fixed. And the top is basically 800,000 the whole time, right? It's
Okay.
really close to 800,000. That's the same reason, but it's like the opposite reason what we just said. When the top was fixed at 1 over here, and the bottom became really, really small, and the bottom became super small, close to 0, you got an infinity. So you just have to reverse these positions. If this is going towards infinity, then this was heading towards 0. Right? 0 and infinity are related in that sense.
Yeah.
Right? Was that not the question you had though?
Yeah, that was like
That's the
part
first
A,
part, or-
and then part B. It just like changes it.
It changes
between
it
the
up.
three.
Okay, so now it
The
switches it.
top goes to infinity.
and the bottom is going towards a fixed value,
Okay,
so it should be blowing up.
so it does make sense that it's going to infinity.
Now they're going to do the one we just did on the board, the cosine, basically. The top's going towards a fixed value, the bottom's going towards 0.
But that's like undefined.
It is, but in this case, how is it undefined? It's going towards infinity. Top's going towards a positive non-zero value, 800,000.
0 to infinity.
Well, the bottom's heading towards 0.
Okay.
So as the bottom gets super, super tiny, the overall fraction gets super, super big.
Why would it get big if it's over 0?
It's never going to be over 0. It's getting really close. The bottom's getting really close to 0, but will never be 0.
Oh, okay. As it gets really small.
Yeah, as the bottom gets really small, the fraction gets super
Oh yeah,
big.
and then the number gets really big.
That's
okay.
right. Yeah.
Okay.
Those things are important to remember. Like think like that.
Okay.
If the bottom gets really small, the fraction gets really big. Bottom gets really big, the fraction gets really small. And then you want to keep those in mind.
Thank you.
And they don't pay enough to have good internet service here. What is wrong with this school?
It's normal.
Yep, and HCC does too.
Uh-oh. HCC is
No.
good about Wi-Fi.
In the library it is.
I've done it everywhere else too. Except for in the cafe. I've never done that there.
Usually when it's quiet there. But it works best in the DH building.
Probably because of like all the English stuff.
Yeah.
So are these chapters up here?
What's today's date? 8th?
Yes.
Thank you.
I thought it was the 8th yesterday.
It's my sister's birthday.
It's your sister's birthday?
My sister's birthday is Friday the 10th.
Yeah?
Yeah.
Tell her random strangers that happy birthday.
Ryan, you know that old probability game, right? If you have 30 people in a room, then 2 people have a birthday. Is it the same?
Man.
Oh, really?
Yeah, we're pretty close anyway. It is. You increase a few, 35. You certainly have somebody.
Yeah,
2 people.
2,
same
3,
day.
4, 30. Yeah.
When's your birthday?
October.
What about you? What month?
Well, no, I'm saying the same day even.
Oh, well, what
Yeah.
month are you?
Well, if you have 30 people in a room, of course you got somebody. If you have 13
Well,
people in a room,
the
you got
same
somebody.
day?
If you have 13 people.
We're talking stats. We're talking statistics,
Look,
are we?
If you have 13 people in a room, there are 2 people the same month, for sure. Right? Pigeonhole principle.
Okay.
All right, fine. So now, so what I'm saying is, if you have around 30 in the room,